everyone, welcome back to the channel. Today we are continue over part 3. Sorry about it, I did not upload it yesterday, so I am doing this today. So here in the first part you have learnt about the data analysis like the part, right? If you have the data set at a beginner level in your hand, from where you should start. Okay, so I have explained step by step in a detail. And second, I have also mentioned the feature importance, which will help you to tell which graph you can draw using the with the help of feature importance for the stakeholder, because it is going to give you the clear picture about the which features might be important for the model. Okay, and we have in the part 2 we have discussed about the how to handle the outliers, missing value, implement the logistic regression, right? Now in the third part we are going to continue about the evaluation matrices of for the logistic regression. As I told you in the part 2, I will add the random forest classifier too, but I will do it in the next part, part 4, because this video was going actually very long. So in part 2, I did not mention you this thing like your data set is imbalanced. This I did intentionally actually. The reason I wanted to show you, if you don't know your data is imbalanced and you are implementing the model, right? So how it is going to affect your performance of the model. This way you are going to learn actually. You will understand the importance of the imbalanced data or balanced data. Today you will learn the 3, 4 your accuracy, precision, recall, confusion matrix. Which one you should use based on what case. We will talk about today churn, right? And then in the next you are going to learn how you are going to handle the your imbalanced data, and then we will do the comparison between two model, imbalanced. Okay, you are going to drop a comment which model is good. Okay, so in the next part we will continue with the random forest classifier. It because this is itself a big model. Okay, and I wanted to show you the random forest classifier also in detail. So that's why I divided it, shift this into the next part. So you don't need to like watch a too big video. Okay. I understand it's very, sometimes it become very hard. So to take everything in a one go in your mind. Okay. I want you to take everything in your mind slowly, slowly. Okay. Okay. Apart from this, there is a one suggestion from my side. Actually, I wanted to make a videos on real-time scenarios or the problems at a beginner level students are struggling for. I love those cases because I want to help other students too who are struggling at the same point where you are struggling. If you are watching my this video, please help me drop a comment and your like the file. If you want to share, you can share your file, contact at sciencedatascience.com, or you can email me. I will be very happy to make a video where you are struggling, so because your struggle can be the struggle of other 10 students too, so they don't waste their time, they don't struggle for the same problem, so we can provide them the solution, because I want to build you strong in AI. This is my goal actually. Okay, I want to help each and every student. Okay, so let's start with the whiteboard. First I will make you understand the confusion matrix, because this is the most important part you are going to deal with today. So let's understand it first in a 5 minute. Okay, so here we have a one table. This is your actual label. This is your predicted label. So our target name is churn, right? So this is your actual churn. This is your predicted by your model. So I will make it a cap on this to make the difference. So let's say you have a 5 cases where your actual one belongs to your no churn and 0 belongs to churn, right? So you have a 2 cases about the churn, 5 cases no churn. This means customer is going to stay. And your model predicted this is yes, he is going to stay. So this is a correct prediction, right? This is also correct prediction. This is also correct. This is also correct. But here your model is saying he is not going to he's not going to stay, he's going to churn. So this is a wrong prediction from your model, because in actual it is 1. He's not going to churn, but your model is saying he will churn. Okay. Now here your model again predicted correctly. In actual you are saying yes, this customer will churn, and your model is also saying yes, he will churn. You are saying he will churn. Your model is saying no, he will not churn. Okay. So it can be the big loss for you, right? Because you don't want the customers to go anywhere. Okay. So now this is we see in classification problem with the help of confusion matrix. Don't worry, you are going to see this. My goal is to make you understand first the confusion matrix, so you can understand the results from the model at a deeper level in the coding session. This is my goal. That's why I'm explaining it first. So here we will name it actual label. This is your predicted label. You can draw it with me too if you want. Okay. So this is no churn. This is churn. Okay. And this is no churn. And this is churn. Okay. We denote it like with this way. True positive, false positive, true negative, false negative. Okay. So we check it actually diagonally. Like this. Okay. So this is the most easiest way to learn this. Okay. You can also draw it like this. Okay. Now I will tell you what is true positive. Look at this. This is very easy. Okay. So look at this. In actual, you have the 4 cases where your machine is also predicting it correctly. Okay. So this is called a true positive. These 4 cases are true positive. Now what is the definition? The values which your model was able to predict it correctly, which were actual positive. Which were the actual positive? But your actual positive cases are 5. This is actual positive, right? This is 5 and your model predicted 4. Okay. So what will be the value of true positive? 4. Right. So this is like this means total your cases were 5, but your model was able to predict it 4 actually, because we are interested. This is your predicted label, right? This is confusion matrix is about your predicted one. And what is a false positive? Only one case. This is false positive. You are saying a customer will stay, but will not churn. But your model is saying he will churn. So this is going to be 1. Okay. Now the next case, you are saying customer will not churn. This is negative case, right? We call it true negative, actual true negative. Okay. So for us, this is true negative. So it is 1 because it correctly predicted. You are saying customer will churn. Your model is also saying yes, he will churn. Now here, this is going to be your, again, your actual value is will churn, but your model says no, no, it will stay. So this is wrong. This is false negative. This is 1. Okay. You don't need to draw it in actual. Actually, it will be automatically predicted because I am making you understand it. This will be printed by based on our prediction value. Actually, this will be done automatically using Python code. You don't need to write it like this way. Try to only understand the logic behind the true positive, true negative, false positive, false negative. This is my goal. So you can interpret the result during the interview. This is the most important question. What is true negative, true positive? What is the like which case you will consider? Okay. So there are so many things we will discuss in the coding part. So this is a true positive means precision. In short, students often get confused between precision and recall, which metric they should follow. So they just blindly apply all matrices, but they don't know which metric they should focus on. So based on that, they can evaluate the model. This is the like the most important part where the at a beginner level student struggling. Okay. So that's why I'm like focusing on this. Your precision means true positive. how much your model was able to predict correctly your actual positive value, that is called precision. And what is recall? When your model is able to predict incorrectly from your positive cases, total positive cases, not actually positive, total positive cases. Okay, so it was this one, so that is called your recall. Example is, if you in actual you know customer is will not churn, but your machine say no, he will churn. Okay, this is recall, but this is not working on not only on the base of your actual positive. This is working on total positive cases. Okay, positive cases means these one. Okay, so now it will make you more understand at a deeper level when we will jump on to the coding part. So let me open my this part here. I have made the little bigger sizes so you can see the screen clearly, the code. Okay, okay. So now let's move ahead. So in our previous part, we have already implemented handling the missing value outliers and everything. Today you are going to learn much more actually. I will also show you the feature importance too, which feature was used most of the time during training by your model. Okay. So this is a new and interesting thing for you too. So here you have seen 80-81%. Your model is not overfitted. This is for sure, right? Because your model is overfitted only and only in case scenarios when your training accuracy is very far away or larger than your testing score. This is a short example. Okay. And it is not also under training because your total accuracy is not below 50% both of one. Okay, or maybe in underfitting your training accuracy is very less, your testing is high, that is also the you are underfitting. There can be two scenarios. Okay, so now we will move ahead. So this is, I have added the just the definition for you if you are looking at my notebook, because I used to share the notebook link. Okay, so this is for your learning. This is the definition. This is a formula of precision. TP divided by TP plus FP. Now I hope you understood what is TP, what is FP. Okay. So now the next one is your TP plus TP plus false negative. Okay. So this is the one. Okay. This is a recall. This is a F1 score. This is a balance of your actually precision and recall. But I will tell you when you should use which one. Okay. So I have written this theory just for your understanding. And now let's start with the evaluation part. Okay. So here from the sklearn matrices, you need to import precision score, recall score, F1 score, confusion matrix, classification report. There is a difference between confusion matrix and classification report. I will show you. Okay. So stay with me till the end of the video. Look at this. When you ran the existing logistic regression, I did not make any changes. This is the same file. Okay. And I did not add any feature engineering step. This is a simple, I am continue from the next step from after the accuracy. Okay. Now look at the result. Precision is 68%. Recall is 61%. F1 score is 64%. And this is the classification report actually. Okay. In an interview, I will tell you this is the most important question. They will always or most probably always ask you what is the difference between precision and recall, and why you are using the F1 score, why you are not using the precision only, what is the reason, and can you interpret the classification report? What does it mean, weighted average, macro average? Okay, so these are the general questions. So you should be able to interpret it. Don't just looking at the percentage, but try to understand what is the meaning of each and every column. Then only you will be the good data scientist. Till you don't understand it, you don't know how to evaluate your model actually, how to improve your model actually. Okay, so here this is a precision 68%. This means your model was able to predict correctly actual positive cases 68% out of the 100% only. This means if you have a 10 records, you have a 5 cases as I have shown you in the example which you have seen in the whiteboard at a startup of the video. So it was able to predict only out of 10, able to predict the 4 cases correctly, which were actually positive. We just giving the percentage lump sum. Okay, so 68%. But we want you want it high In what scenario? Now, tell me. You want it high if you are saying customer will not churn and your machine is saying no, he will churn. Okay, you will start sending them the promotion emails, right? So in this case, you might be like need to, your marketing team might need to struggle with writing the emails or sending, but still there is a no loss. Okay, but now look at the recall, 61%. This is very less, right? Your model is not able to predict correctly the total positive value correctly. So recall is less, right? 61%. But in your case, what will happen? If your machine, you are saying customer will not churn in a actual, right? And sorry, you are saying customer will, yes, you are saying not churn and your machine is saying he will churn, right? Or in other scenario, your actual problem is machine is saying, sorry, your actual problem is like not, sorry, churn, and your machine is saying not churn. So this is a big loss for your bank, right? Your company, right? So here over like this recall is going to cost high for our bank, right? Because we want to stay the customer, we don't want to go the customer. But if your machine is no, in actual this customer is going and your machine is saying not churn, then you will ignore that, right? You will not be able to send any promotional emails to stay them back. You are not able to give them the discounts or other promotion emails what you do. Okay, so this is a loss. So in our case, we should improve the accuracy, we should like increase the cases of this thing, right? 61%, we want to increase the percentage of recall because we want to know actually what is the result. Your machine should also predict it correctly. Okay, so this is the way how you will like choose the metric. Now compare this precision and recall with the accuracy. Using this single number, were you able to know how many like your machine was able to correctly predicted the actual positive cases, or how many were you able to check here with this number how many your cases your model was able to predict which were out of the total positive cases? No, right? If you are looking at even at a 95%, you don't know on which class your model is giving the priority, right? Minority class or major class, positive class or negative class, we don't know. So that's why don't rely on the accuracy, especially in case of classification. Apply the confusion matrix, apply the precision, apply the recall. This is the most important part. This is I wanted to make you understand actually. Student apply the matrices, right? Only accuracy and they stop. This is the most common question. Should we apply all matrices or not? Either you are doing the regression work or classification, apply all matrices. Don't rely on the single number. This is not going to give you any result in detail. Okay. So now, because based on the false positive, false negative, I know which case is cost us high to my company, right? If a false positive is going to cost us high my company, then I will focus on recall because I want to increase or decrease a false negative, right? My machine, if my customer is going to churn, my machine should also say it is going to churn. If it is not going to churn, my machine should say no churn. But if my machine is saying no, he is not going to churn, in actually he is going to churn, I will lose my customer. So based on that, you can decide this thing. That's why this is important. That's why I'm focusing on this. This is the most important part. Believe me, if you understood once this thing, your model will never fail in classification. And you will do the very good evaluation or improve your model. At start, it will like it's hard. I understand at a beginner level, it's hard to understand. But believe me, you will understand. Okay, and then here we will go with the F1 score. F1 score is nothing. This is a balanced combination of your precision and recall. But I will answer you at the end of the video when you should use which one. Okay, so now we are considering one case right now. Okay, Maybe you want to balance both things, right? You don't want to send the emails to the customer who is not going to churn. You don't want to disturb them. Maybe customer will leave your bank if you keep on sending them the extra emails, right? We got frustrated. Why they are sending me the emails again and again? We might want to block them, right? So this is the problem. F1 score is the combination of balanced your recall and classification. This is a formula. Okay. And then look at this classification report. This is, I love this report. You know, it is telling me each and everything. Look at this. 0 means churn, right? So precision is 86% in this case. Okay. And this is 1. This is precision is 68%. So this means 1 means actual value is 1, right? My customer is going to stay and my machine is also saying yes, he will stay. But it was only able to predict 68%. But in case of like a 0, not churn, it 86%. So this is very high, right? So in our case, we want a high precision, right? Because we want to know which customer is going to churn. So we can send them the promotional emails. Now look at the recall. If the customer is like a 0, like not like a churn, my machine is also like saying yes, he is not going to churn, sorry, churn, right? And in the same of case of this, right? In this case, maybe you want to like reduce false, you want to increase the your true positive cases, decrease the false negative cases. Okay. And if for you churn case is most important as per our revenue, for us churn is more important instead of no churn, right? Because we want them to stay back. So your false negative, false positive is more important. Now decide which one is more important, which you want to reduce. You want to reduce the false positive, right? You want to reduce false positive and you want to, in case of, we will go back here in the confusion matrix. Okay, so we will look at this. So this is true positive, this is true negative, this is false positive and this one. So if your customer is not going to churn, right? Your machine is saying, yes, he is not going to, sorry, your machine, in actual you are saying churn, your machine is also saying, yes, he is going to churn. So we want to increase the value of true negative. Okay. So here this is showing you the percentage of that. This is the balanced score. Okay. SMOTE is sample of data. Okay. Now look at this. It seems to be imbalanced, right? Your zero belong to this class, 0 class is very, you have a many data points, but belong to your first class, like churn data, no churn data, you have a very few samples. So you come to know your data is imbalanced. This is I wanted to show you, actually I will show you. Okay, so macro average, weight average is, macro average is your multiplication of with each sample this data point. This is the average. It will multiply the each sample with your precision or recall number and then take the average, sorry, multiply with the weight and then take the average of this one. Okay, I will make a separate video on this with the formula so you will understand it more how to interpret the classification report, but this is just the overview. Weight average is very important. This will also consider the each sample again, and but it will take the, it will not multiply with the weight, it will take the average of that total weight. Okay, and here now we will move ahead. Look at this. So I have tried to draw the your confusion matrix in very good way. So we will declare here a confusion matrix. You need the Y test, Y prediction, because this is actual or predicted one. This is I have shown you on the whiteboard, and here I have divided it into this. So you can understand the values which is we need to print it. How many true negative cases, false positive. So that's why I'm doing for your understanding. And this is the confusion matrix form we are declaring. I'm using the seaborne heat map confusion matrix form. Annotation is true, format is D, blue. You can use any, this one, there is no problem. Tickables, we have set no churn, churn, no churn, churn. This is just write down as I have shown you in the whiteboard. Now look at the result. This is a result from the imbalance data actually. This is actual predicted, this is predicted one. Now look at this. This is the imbalance. So nine to nine cases, your machine was actually able to predict it correctly. Okay. Out of how many cases, if you do the addition of these, out of this. That's why your precision was high there. Okay. Your precision was high. And then here, this is it was not able to correctly predicted where the customer is actually not churn, but your machine is saying they will churn. This is a 107 cases. So you will start sending the emails to 107 customer. But this is the wrong result. Okay. And look at this, the churn one. This is your, what is this? This is your true positive, false positive. This is your false negative, true negative. So this is your true negative, sorry, your false, this is false positive, this is false negative, sorry. Okay. So this is 147. So you know, you can do the plus of 147 plus 226. It will tell you the total cases. So out of that 147 cases, it is saying the customer will not churn. Actually, they are churn. Okay. So this is the difference. Okay. So churn means it is like predicting here true negative. It is saying churn, right? And this is also churn. But you are saying no churn, right? But it is actually churn. Okay. So this means this 147 cases belong to your what? False positive, right? This is true negative. And this is true positive, and this is false positive. Sorry, this is your, uh, here we go, false negative. Okay. So this is what happened in real time. Actually, it's very hard to memorize this thing. Okay. So now just look at this. So now if I look at it carefully, even though here the number of samples belong to this one is very high. So this told me already your data set is imbalanced. My model is focusing more on the majority class, which is 0. It is not focusing on the first class. It is minority class. Okay. So our data set is imbalanced. Now our next goal is to make it balance actually. Okay. And if you want to like look at the percentage form, this is also there. This is nothing. This is just the difference in the drawing. So this is 90%, 61%. This is more easy to handle. Okay. So this is 0. This is the 1. This is 0. This is the 1. We know this is your churn. This is not churn, right? So you can also draw this graph if you want. I love this one. This is easy to understand for me. So this is your choice. I have given you the both options. Okay. So now we will here first. Before handling the imbalance data, I am going to tell you the coefficient weight. This is the most important part. So I am going to show you the how much weight assigned to your each data point so it can predict correctly by the model. This is the backend calculation I'm going to show you. This is very beneficial because if your weight value is positive and higher in a value, this means your model has given the more priority to that class in your data set and add the more weightage to your that data point. This is you wanted to know, right? You have seen the formula mathematical like your y is equals to mx plus b. How you are adding the weight? Remember b1, your b naught x1, b1 x1. So what is your this value? Weight, right? You add the weight. So it can predict it correctly. Your model gives the weightage to the each data point. Then it learn the patterns and predict. This is the backend process, right? So this is you are going to learn. Here num features, we will just pick up the number columns because this is only work for the numerical data. Categorical feature, this is the one. Okay, all features name. So we will look at this. This is work with the numerical data means I'm talking about the machine. So here, this is the categorical feature. We need to pick up this data which is already transformed because this will not understand the categorical. I am picking up the from my pipeline which I have created above the model pipeline logistic regression. I changed little bit name. Earlier I was using the model underscore line. So this is the pipeline for your logistic regression. So it make more sense to you. We are taking the get features name out for the categorical column. All features name, we will concat them into the one list. Here is the your population, sorry, coefficients named underscore step classified coefficient 0. This is a code. You will get the coefficients value, the value of the weight assigned to each data point by your model when it was getting trained. And then we will ensure we have the same number of the feature name and coefficient. This is just the check using asset method. And then feature importance, we are creating, I have created the data frame for you. Now look at this. This is your feature. This is coefficient. This is absolute. The difference between coefficient absolute is just a negative value is converted into positive value. That's it. No other difference. Now look at this. So it is showing you the weightage of the each data point. Look at this. Okay. So negative value means it is giving the if your streaming TV, yes, is going to increase or decrease, your prediction is going in opposite direction. If it is increasing, this is going decreasing. If it is decreasing, it is going to increasing. Negative means this means negative correlation. Okay. Positive correlation is this one. Look at this tenure. It is coming on the top. Okay. So it is showing you the here the value of the how much it is give the weightage 1.33. This is the coefficient weight it is giving to the tenure. So this means this is very important for your model. If the customer's tenure is he is a high, let's say 34 months, 24 months, this is going to be stay high chances, right? So this is going to help your prediction. Okay. And it is showing you the second your important contract two features. So this is the weight according to that one, your data point weight. Okay. So you can read it about it thoroughly, but this is basically I wanted to show you. These are the weight assigned by your model at the back end, and then it is also giving telling you this your tenure is helping 1.33 above your this percentage. This is helping your model to predict your data correctly, and 84% your contract to year. Then total charges, this is going down. Okay, so this is all sorted. That's why this number is not in sequence, because we have sorted based on the coefficient value, and it is in the form of descending. Okay. And now I will show you here you can see the graph too. This is the same feature importance. This is the coefficient value negatively correlated, positively correlated. So it is also like for you to look at it negatively correlated. This means if your tenure value is right low, like let's say 3 months, 2 months, your customer is going to churn, right? Because he's not going to stay. Might be he is looking for the different options, right? And then he's just checking your bank what benefits you are going to give them, right? So that's why this is negatively correlated with your prediction. But this is pushing your your prediction towards the correct prediction. This means if you in actual your machine you have the data, customer will churn, your machine will also say yes, he will churn. Okay, but they are negatively correlated with each other. So this is also the graph. Instead of looking at the numbers, you can also look at this. On the x-axis it is showing you positive, negative value, negative weight assigned, positive weight assigned. Okay. And then this is a Shapley additive explanation. This is my one of my favorite. I love this because it really helped me to understand which feature was used most of the time by my model for the prediction. Okay. You may be thinking, we check it using the correlation too before model building. Yes, this is the one part, but this is before model building. Sometimes it show you, but at the back end, sometimes models are using something else too at a bigger level. We don't know even have idea. And we usually delete those. Like if you were thinking earlier to delete that, like the feature, and you saw, oh my God, my model is using most of the time this feature, then your decision was correct at that time, right? So you can match that. So that's why this is very important. Here we need to, again, I'm saying if you are using the pipeline, you need to use the transform data because this is something work based on the numerical data only. Okay. So this is explainer. You need to import the SHAP library. If it is not there, you can install it. Sorry. Explainer, SHAP.linear explainer, model pipeline named classifier, extrain, transform, SHAP values. This is you need to go to calculate. Okay. And then this is a summary plot. Okay. There are more graphs too, but I have drawn this. There is a force plot too. If you want to take a deep dive, I will share the link of the library. Okay. SHAP value, this is the negative correlation. This is a 1. Blue color belong to low value, low SHAP value, and red color belongs to the high SHAP value. Okay. Don't get confused in this. This is a low value, high value. We are not talking about here positive, negative. Okay. High value can be in the negative as well. Okay. Just keep in your mind low value, high value. Low value belong to blue color, red color belong to high value. Now look at this tenure. This is showing negative value too and positive too. How this means your tenure is helping your model to predict the values, helping to predict the values correctly, or helping the model to predict the value. It pushing the model towards the prediction, pushing the model towards the prediction. I'm repeating this line. This is the purpose of these tenure. We are just looking at it. Either it helps in with the negative weight or positive weight. Negative means like your tenure value is very high. This means your customer is connected with you or stay in your bank since 34 months, 50 months, or maybe more than 25 months. It's a long tenure. But in blue means low value of the tenure. This means 6 months, 2 months, 3 months. Okay. So that's why I am saying you. Okay. So you need to understand it in a very clear way. Listen me again. These SHAP values is showing you how your model is using the SHAP value or this feature and or helping this feature for the prediction, or in other words, which your feature is pushing your model towards the prediction, helping the model. Okay. It can be the negative high value, it can be the positive high value. Okay. And this means your tenure is helping in both ways. And look at this total charges, low value in a negative, right? Positive value high in this means if total charge is increasing, customer is also in your favor, right? It is going to predict, it is going to stay, no churn. This is our goal, right? And this is for other one too. Okay. So this is very small value, not high, but monthly charges it seems to be good, total charges and tenure too. Okay. So this will give you the idea now. You can try this if you are working on the house sale prediction, you can try this map. Okay. And now methods to improve the accuracy of the model. We have a, you can add a new feature, you can binding the feature, you can how to fix the problem of imbalanced data. I'm going to discuss this one because this is itself a big like piece of code and explanation. If you want me to make a video on this too, I will show you the same real-time data set case too. I much appreciated. If you really want me to make a video, you can drop a comment. Nija, make a video on using the add new feature. I will tell you how it will improve the accuracy. But we cannot cover everything in a one video. So that's why I'm picking up this one. This is the important or priority part for your this data set. Okay. And then methods to improve, we will use how you can balance the data, imbalance data balance. You have these strategies. Either you will add a more weight, right, to your all data points. You will use a random oversampling. You will use either random undersampling or SMOTE. I'm using first and fourth method today. If you want to learn this too, just let me know. Okay. And then here I'm going to show you the how it is imbalanced. I have used here your this graph, the bar graph. Look at this. So churn 0, 1 is yes. So you can see not churn, you have a very much high score. That's why it was you can say 90% of the true your negative cases, sorry, positive cases, right? So this was the reason. Your precision was high, right? Recall was also. So here the one, right? So this is imbalanced. So this means the data points belong to your one category is minority class, belong to minority class. Here it is giving belong to majority class. So what is the nature of the model in general? Your model will always give the priority to the majority of the class, because during the when we are train the model, your model think this is the majority class, so I need to give the more weightage to this one. Okay, this is how your model work at the back end. That's why it's very important to check the imbalance. This is I wanted to show you, and you will see the difference too in the confusion matrix value too when we were done with the handling of imbalance. Okay, so now we will move ahead. This is I'm showing you the percentage. You have 73% data of belong to zero class, only 26% to this one. So your model will definitely going to be biased. You have seen it is biased, right? Not in the accuracy, actually. That's why I told you accuracy is not the correct way to always check the classification. I never rely on the accuracy. This is good for your simple or regression problem. In classification, I don't rely on that. Always go with the confusion matrix. You have seen the difference. Okay. Now we will balance it. First, you can pass here the class weight balanced. Okay, so this is an inbuilt parameter. If you want to use this before building first model, you can also do that. My goal was to show you the difference. That's why I'm doing it right now. And then we will scale it. As I told you, it's mandatory to scale your data because they are in the different units. Okay, if you want to learn about it in detail, you need to look at my part 2. Okay. We will again make a pipeline. This is I have already explained in detail in part 2. Okay. So here we are fitting on to the transform data. I have picked up the transform data. This is from our previous part. Okay. And then look at the result. So this is your classification result. Okay. And now if we come here, so we will run this. And now we will run this too. Okay. Now look at the result. This is now showing 749,309. Okay, and this is 64 and 287. So what was the previous result? So we will pick up now this one first, and you are this one 309. No, or this one 749 or 644. Sorry, 64. Okay, because we want to reduce that, right? So we will come here now. Comparison, see there is a big difference. So I was a when I have used class is equals to balanced, it is giving the equal weightage to all data points, majority and minority class at the back end. Your model will automatically add the heavy weight value to the minority class to balance the both classes when you use this parameter. So see the huge difference. This is what we wanted to increase, right? If the customer is churn, my model also should say, yes, he is going to churn. So I can start sending them the email. You can see the huge difference there, right? There was a 64, here is a 147. This is the magic of like handling the balance data. Okay. So this was the one part. And if you want to here, I think this is just the name of your this one. Okay. Okay, so it was sorry about that, that was the wrong way. So it is in the form of percentage, nothing difference. Okay, so you can see it is reduced to 17%. Okay, and then I am applying the SMOTE method. This is very popular method. The difference between class weight, class is equals to balance weight, and this one is in that model will automatically add the more weight to the minority class to give you the good prediction. SMOTE method will generate the synthetic data. Okay, similar to your existing data point in the minority class. And mind it, SMOTE is only and only implemented onto the trained data. We never implement it or fit onto the test data, otherwise there will be the data leakage. Don't try to fit or use on the test data, only for train data. Keep in your mind, this is the key point. Okay, so now we will pick up the imbalance learn dot pipeline. This is not from scikit-learn, and then we will make a different pipeline. This is especially for SMOTE. And then random undersampler, we are not using this library. If you want, I can make a new video. Just let me know. Drop a comment in the comment box. sklearn classification and confusion matrix display. This is from your IMBlearn oversampling imports mode. It will generate the synthetic data based on the minority class data, similar points. Listen it carefully. It will generate the data based on the minority class maturity and balance them. And then we are using maximum iterations. This means that your model is going to run your samples in this much loop, iterative over 1,000 times of your data points. And then make a sampler pipelines. We will scale it, pass the SMOTE instance, this one, and logistic regression SMOTE, which we have declared here. Okay. And then we will fit onto the train data and then predict on the text data. And here is the output. Now, instead of looking at the classification report, we will look at this. So it increase this one, there is a no effect on this, right? This is same. And this is increasing. So it is like increasing this one. And this means it is going to decrease this one. And now if we want to compare this one here, this is 309. Definitely this is decreased. So your model was able to predict correctly if customer is no churning, it is increasing the power of that, right? And this is the one, it is increasing. So this is the advantage. Now you have used the two methods, SMOTE and class balance. My goal was to show you the two methods. This is your choice. If you want to use a balance method, you can. If you want to use a SMOTE method, you can also use that. It totally depends on you. Okay, because there is if we look at this, our goal was to reduce this point, right? The 64, the churn. If customer is going to churn, my machine is, this is showing same result for both. Okay, you can try. Sometime values go up and down. Maybe you pick up the data set, different churn data set, then your values will be different. Don't try to match the accuracy or values with my data set. Maybe there is some different data set you pick up from different sources. Okay, so it might be different, but don't get confused. Only try to understand the logic and the process. This is important. Okay, if you understood the process, then you will automatically understood everything. This is the thing you should keep in your mind. And now, which metric you want to use now? Tell me. Do you want to use precision, recall, or F1 score? You can use the precision if you are more in, if the false positive cases costs you high. This means if in actual you want to focus on only and only model to focus on, tell me which customers are not going to churn. You are only focusing on that thing, then your precision should be high. Okay, so this means your case will be to reduce the false positive cases. Okay, in that scenario. If number two case, if you want to focus on, no, tell me which customer is going to churn, predict it correctly, then your goal is to reduce your true false negative cases, right? You want to reduce this value, false negative cases, because if customer is going to churn, your machine also tell you yes, he is going to churn, so you can start sending them the emails. Okay, so for me the second case is important because I don't want to lose the customers. On top of that, F1 score we use when your data set is imbalanced. Okay, so F1 score because it will give you the balanced output. If it is higher the F score, this means your prediction is good, your model is good. Lower the F score, this means there is something which is you need to improve. So it will give you the one number, but it is also telling you the about this point too. Here we have calculated the F1 score, so we will go above. Here you go. Here it is your this one, right? The 64%. And if you want to, let me check if we will check for the last one, SMOTE method. So here we go. Okay. So we can print it here too. Okay. So there is your here that we need to make some changes in the variable here. So this is, I have made the changes here, the test prediction, this is the one, and it is showing us still 64%, but your data set is balanced now. So you can go with the your second option, that is the recall. Okay, because I want to reduce the my true negative cases. Or sorry, your sorry, I want to reduce my your true negative cases, right? So in this case, I will come here. So this one, if your customer is going to churn, my machine should tell me this is it is churn. Okay, so this is false positive, this is false negative. Okay, I will correct myself. Sorry about it. So this has happened in the confusion matrix. Okay, so you need to reduce your false negative, right? You need to increase your true negative. Okay, so this is important. This is you need to keep in your mind. Here you can now understand sometime, or you can see me, like when we are discussing this thing, we got sometime confused in this. So here I will add a one tip. Take a notebook, make a like a confusion matrix graph, label it with the true positive and that values along with your this numbers too. Okay, so it will be very very helpful for you if you can plot on the graph. This is great. Okay, instead of churn, no churn, you can just draw the your true positive, true negative, and those things too. Okay, and add the more ticks on that. Okay, so this will be very very beneficial for you. So now this was the all about for your evaluation of the model. You have learned how you can use the sharp values and your coefficient to check which the feature was used most of the time. And you have also learned how to balance the imbalanced data using class weight or SMOTE method, right? If you want me to make a video on another feature engineering part 2 using the same real-time case, just drop a comment. I'm happy to help. Okay, and I really appreciate you if like you if watching my video. And if you are new to my channel, don't forget to subscribe the channel because I am going to keep continue this journey. I have another playlist too about the stat, your data visualization, and about the Python. I used to make a video on every topic once in a week. Sometimes this week I am just to get with the flow. I'm making the videos on the machine learning only. So in the next video, we will discuss about the random forest classifier. Okay, so keep watching, keep learning, keep patience with science data science. Don't forget my suggestion. If you're struggling at some point, please share with me. I will make a video on that so other students can also learn from your problem too. Okay, so let's help each other. Okay, thank you.